Hello, my name is Dmitry Yumashev. I work at the Pentland Center for Sustainability and Business, Lancaster University, UK. And in this session, we're going to look at the opening of the Arctic to commercial shipping. The structure of this session is as follows. First of all, we'll look at the opening of the Arctic to commercial shipping in the past, present, and in the future, namely because of climate change. We'll look at the different Arctic sea routes and their importance for the world. We'll consider factors determining the opening up of the Arctic waters to commercial shipping. And finally, we'll look at the impacts on the Arctic and globally, winners and losers. There are two major transit shipping routes through the Arctic. The Northern Sea Route, which goes off the northern coast of Russia and provides up to 40% shorter distances than the Suez Canal route between Europe and East Asia, and the Northwest Passage, which goes off the northern coast of Canada, providing up to 20% shorter distances than the Panama Canal route. There are multiple destination shipping routes in Nordic countries, Russia, Alaska, Canada, and Greenland. A significant sea ice loss in recent years, driven by climate change, has led to greater marine accessibilities in the Arctic Ocean along all those routes. Present-day activities in the Arctic include summer sea lift to remote communities, fisheries, oil and gas, minerals, tourism, research, and cargo transit via NSR, Northern Sea Route, and Northwest Passage. That will be in the focus of the remainder of the session. The history of marine exploration in the Arctic goes back thousands of years, coinciding with the rise of the Inuit and other indigenous cultures in the Arctic region. But the first idea of a northeast passage from Europe to China via the Arctic goes back to early 16th century Russia. Then the Netherlands and Britain, the rising maritime nations of that time in Europe, took that idea, and that resulted in Barents expeditions to the Northeast Passage in the late 16th century. Multiple expeditions followed, mostly driven by Russians, including the one by Bering in 1725-30, while the Northwest Passage was explored mostly by British, including Franklin's expedition in 1845. The first complete crossing from Europe to Asia via the Northern Sea Route, though, took place in 1878, while the first traversing of the Northwest Passage from Greenland to Alaska happened in 1906, and the expedition was led by Amundsen, who went on to be the first person to reach the South Pole a few years later. Why are trans-Arctic sea routes important? Shorter distances imply reduced shipping costs, less fuel, shorter ship running times, while at the same time they reduce cargo delivery times. For example, the Northern Sea Route between Europe and East Asia will cut the travel times roughly from 35 to 25 days. These two factors imply reduced trade costs, according to the commonly used iceberg trade model. And this model implies that the longer you ship the goods, the more of their value melts away like an iceberg. So shorter trade routes are preferable economically. And as a result, a fully operational Northern Sea Route could increase trade value between Europe and East Asia by up to 6%, which is a lot. So who will be winners and losers from the opening up of the Arctic sea routes? Up to 5% of global trade volumes, that is 2/3 of the current Suez Canal traffic, could be shipped via the fully operational Northern Sea routes. The biggest winners from this will be Northwest Europe, China, Japan, South Korea, and these countries are set to add up to 0.2% of their GDPs because of the increased trade via the Arctic shipping routes. Russia is also set to gain through transit tariffs and infrastructure developments like the port of Sabeta. And the biggest losers will be, of course, the Mediterranean countries, Egypt in particular, because of the Suez Canal, and South Asian countries. At the same time, there will be increased environmental risks because of Arctic shipping: oil spills, soot emissions, sulfur emissions, noise pollution. These will affect local ecosystems and communities. And finally, recent studies suggest that there might be a net climate feedback of the Northern Sea Route, that is, the emissions from the shipping when they are rerouted to the Arctic and other emissions associated with this will provide net warming globally, despite CO2 reductions. Which factors determine the transfer of the shipping to the Arctic? First and foremost, seasonal sea ice conditions in a changing climate. There will be longer navigable season and more accessible routes. There will, of course, be expenses for shipping operators, tariffs, icebreakers fees, insurance costs, investment in ice-strengthened ships, that's perhaps the biggest factor, infrastructure requirements like search and rescue in the Arctic waters. There will be uncertainty due to variable sea ice conditions, which will affect the business models. And of course, there will be also emission control regulations in certain parts of the Arctic. At the same time, there is macroeconomic pull through reduced trade costs that will drive the growth in Arctic shipping. And finally, geopolitical situation in the Arctic will play its part too. In a recent study, we looked at projected buildup of the traffic on the Northern Sea routes. The scenario used here is characterized by very high levels of emissions globally that leads to excessive warming, up to 5 degrees by the end of the century, and a complete disappearance of Arctic sea ice by the middle of the next century. Despite these favorable conditions, at least from the point of view of the loss of the sea ice in the Arctic, you can see that the traffic takes several decades to build up, starting from around 2030s. And this is because of the restrictions that face shipping operators in the region. So the traffic that we see now and that we're expecting in the coming decade or so is still a sporadic traffic, and it will not be a major development until the business conditions for the shipping operators are met. You can see in this plot that small bulkers and tankers will start rerouting first, and then the large cargo container ships will take the longest before they can reroute. To conclude the session, let us look at climate feedback effects of Arctic shipping. Ship engines have used heavy fuel oils, which are some of the dirtiest fossil fuels, with high levels of CO2, particulate matter, sulfates, and other aerosol emissions. Emission reductions in the shipping sector has lagged behind decarbonization in the wider economy. Shorter distances and slow steaming in the Arctic routes, that is moving at slower speeds for safety reasons, means less CO2 and hence less warming globally, but it also results in less cooling from sulfate aerosols emitted by the ships. Soot is more potent in the Arctic because of higher solar absorption in the summer months. And recent studies suggest that when you combine all aerosols together, there will be net warming effect when shifting 1 ton of fuel from southern sea routes to the Arctic routes. There will be also additional economic growth due to the Arctic shipping, and hence more CO2 and non-CO2 emissions in Europe and East Asian countries. To conclude, here are the results of our recent study on the winners and losers from Arctic shipping. In the blue bars here, you can see the regions in the world that will gain from the better trade. That is European Union, China, denoted as CA, and Japan and South Korea, denoted by OT here. At the same time, the net climate feedback of the Arctic shipping will result to extra warming globally, and that will cause extra losses from climate change. These are represented by red bars in the plot. And you can see that the biggest red bars, are in India and Africa. So this raises an important question that the gains and losses from Arctic shipping are distributed inequitably. And even though Arctic shipping has a net benefit globally, we have to bear this in mind. Thanks very much.